So my name is Oleksii Barash, and I'm working for Reproductive Science Center. It's not far from here, about 30 miles south. And what we do in our clinical practice, we help people become parents, actually. So we have 7 physicians and total about 100, probably 20 people, staff members. And we are one of the largest clinics in West Coast. And we have several thousand patients every year. So what is infertility? By definition, it's an ability to get pregnant within 12 months. And unfortunately, it's about 12 million people, actually, only in the United States, who will never have kids unless they're going to see the doctor. And the good news is, if they're going to see the doctor, half of them actually will be able to have kids, and they will be able to become parents. Because of the natural complexity of this process, this kind of treatment is expensive. It's from $10,000 to probably $100,000. That's why not all the people who actually need this kind of treatment can afford it. But overall, in the world, with the latest available data, it's about 1.5 million of treatment cycles going on in 2014. And I believe by 2018, this number probably was at least doubled. And you would ask why we have more and more patients, right, who cannot have children. And the obvious answer is because people try to get parents older. So like we have a lot of patients who are 35, 36, 37. And as you can see from the graph, at the age of 35, they're actually not, sorry. At the age of 35, there's actually not much fertility left. It's about only 20% left. And by the age of 40, it's very close to 0. I think that IVF in general, it's very close to manufacturing because we have patient, and the patient for us is in the middle. And we have physicians, nurses, we have MAs, and we have lab staff, clinical staff all around. But because we have constant intake of patients and we do complex procedures, it's all like manufacturing. But the bottom line, the outcome is one healthy baby. So what has changed, you would ask, why we have to use ML right now to basically be able to provide good health care? And the obvious answer is data. Because of all the medical health records that we right now have, everything becomes digital. And every new piece of equipment right now we're buying or new technology we're introducing, they all have some kind of connectivity. They all get connected to the internet, and everything produces a lot of data. And in general, if I will have to explain in vitro fertilization for you in a few sentences, it's basically the couple would come to the doctor, we give them a lot of drugs, and then we will create human embryos in the lab for this couple. And usually we create between 0 to 30, depends on the clinical parameters of the patient. So as you can see, we create these embryos and we culture them in the lab in these black boxes, basically, which we call incubators. And we're trying to mimic all the conditions of the human body in this incubator to let the embryo grow as the best it can. But because we culture the embryos in the lab, all the features like pH, concentration of the salts, amino acids, everything should be controlled. It's a lot of factors to consider. And recently, with new equipment that we can employ, there's these incubators, these black boxes with embryos inside. Right now, it's possible to have these black boxes with a microscope. So instead of basically taking embryos once every day or every other day and look at the embryos in the microscope, it's possible to take pictures 24/7. And then, of course, as soon as you get pictures, it's possible to apply computer vision. And by basically applying a special field of the microscopy, it's dark field microscopy. The cells in this microscopy looks like white circles. And by applying computer vision, we can basically track individual cells and also see what size of the cells. We can see how they cleave, how they move, how they divide. And we can do time series, saying in machine learning terms. So basically time between cleavage cells. And this technology actually was developed not far from here in Stanford almost 10 years ago. And we were one of the early sites where this technology was tested. And Of course, as soon as you get data, you can basically compare patients and embryos with good outcomes and patients who didn't have good outcomes, and based on this, create a model. And for the future patient, you can use this predictive model to basically separate embryos with good potential for the future and with the embryos who have low potential. Because, as I said, most of the patients will have several embryos, and they're all different because they all basically have different genotypes and all produce human beings. But recently, we got even better tool. We got next-generation sequencing. So what it is, it's because the cost of the sequencing right now is super low. 20 years ago, it was almost $100 million to sequence, which means just read letters in DNA per person. But right now, it's less than $1,000. So right now, even though we do thousands of patients, 90% of these patients will have genetic testing. So what we will do in the lab, we will have an embryo, right? And then we will cut 4 to 5 cells with a laser very precisely and send these few cells to genetic lab. And genetic lab will tell us a lot of genetic information about this embryo. So we will know how many chromosomes this particular embryo has. We will know if it's boy or girl. And if patients have some kind of genetic disease, we can select embryos that will not have genetic disease. So we can produce only healthy babies. So this technology impacted a lot of our workflow, and this was the main driver, because even patients who are advanced maternal age, like 40 years or older, have a chance to have a healthy baby. But unfortunately, as female gets older, the proportion of the abnormal embryos decreases significantly. So this is just was a few examples of new technologies we're currently using, but there are several more. I just don't have time to explain it. But in general, I think you got the idea that we have so many data from all different directions right now in healthcare. So our goal was, what if we can evaluate all the available factors right now? Because we used to think how feature A or B will affect our outcomes. But right now, because we have so many features, we'll try to make sense of it. And of course, there is no way we can do it manually. This data is too big to analyze it manually in old school ways. So we have to apply new tools like machine learning. And we started a couple of years ago with classification and regression trees, which is basically very easy to interpret and delivers information to the patients and to the physicians. Because basically, as you can see in the bottom, there's terminal nodes, and we know with this set of features, these embryos produced pregnancy or didn't produce pregnancy. And our data set actually not so big. We have about 300 features and about 11,000 rows. But because we have more and more patients like this, we will add probably like 5,000 rows every year. So this data set become more wider than deep. And of course, as soon as we have some reliable model, we can extract the features, which is in clinical practice is very useful for us, because these features, in many ways, we have to prioritize what we have to look exactly for this particular patient. So we know which feature will affect the final outcomes the most, and so we can concentrate our attention on these particular features. And even though our data set has only weak predictors and not so big, we were able to get decent accuracy from this data set. And of course, one of the best tools that we were using was Driverless. We always actually use Driverless as a benchmark because it doesn't make any time. It's just plug and play, and we get already a number. And I like in Driverless this feature transformation feature, which is awesome, all these complex transformations. Also, sometimes when we need to get some clinical answer fast and you have data set you're not super familiar with, you plug it to the Driverless, and then you will be able to actually see the data leakage right away, because you see feature importance and you see, oh, yeah, this feature should not be there, and I should have deleted these features before I plug the data. So the bottom line of all of this, we basically we can estimate the chances of any particular embryo to establish the pregnancy, which is basically classification task, because on our training data set, we know this patient was pregnant or not from this embryo, and there's yes or no situation. But when we do predictions on a test set, it's always probability, because it's continuous function. So we actually use probabilities as a number, as a final number that incorporated in itself all the other features. And this number actually can be used for embryo selection. So we know this embryo has better chances to produce a pregnancy. But not just this, also there is valuable tool to consult the patient, because if we know this patient have embryos that doesn't have a good chance to produce a pregnancy, we can deliver this message and patient can have special adjustment for the future, because he can make or she can make a financial adjustment, because patient knows that these chances with this particular set of embryos for particular patient are not so good chances. And as you can see from this graph on the right, we right now can deliver information, not just telling the patient, our average pregnancy rate will be 63% as is today. We can say, you have chances about, let's say, 40%, but other patient, we can tell your chances 70%. So this is more accurate and more sophisticated information, and this is very personalized information because even though the features are the same for every patient, because the features are different, the values are different, the prediction is going to be different in the end. So what next? In general, I would say it's all about personalized clinical decisions, because and these decisions actually for the patient, because patient can basically know what my chances to have a baby, or can I afford it? And also for the physician, because physician can have clinical decisions based on what's the value of the drugs I should use, what kind of drugs I can use, and also a lot of decisions can be made in the lab based on the data from machine learning, because we can sometimes adjust our protocols in the lab, change something, tweak something, and then see how it will affect the final outcomes. But the downside of all of these predictions and algorithms is that we cannot easily transfer this algorithm to other clinical settings, because they have maybe different protocols, different patient populations, different drugs they use, or different equipment. So they basically will have to do the same what we are doing, but in their settings. So most likely they're going to have pretty close results, but a little bit different, because these curves will not be the same. And what lies beyond? What is next? It's kind of a creepy picture, right? But this paper was published a couple of years ago, actually, in Nature. And what it says basically is that researchers were able to culture animal for 4 weeks in the lab. And this technology will be able to help tremendously in the next few years to the patient who delivers the babies extremely premature, like 20 weeks of gestation. Because right now, these babies will just die. But if we will have possibility to culture, to sustain the growth of this baby in the lab, we will be able to save this baby. Or another example, if we already have a microscope inside the incubator and we're taking a picture from the embryo, it's possible to take not just one picture at a time, but hundreds of pictures on different focal planes, and then combine this picture to build 3D models. And I personally believe in the future we will be culturing embryo from inception like we do right now, but not 6 days as today. We're going to culture them all the way through 9 months in a lab. And of course, as you can guess, it's going to be a lot of data. I know it sounds like a matrix, but as soon as technology will be available, a lot of people will try to use it. So as a conclusion, I would like to say that ML actually is not widely used right now in clinical practice. We're just in the beginning, but the power of making decisions with ML is great, and AutoML is a great tool for the rapid and knowledge discovery that we can make decisions right away, and it can be personalized decisions. I generally see transition from knowledge-based clinical decisions to the data-driven clinical decisions, and there is more and more demand from the physicians to get these clinical decisions based on data, because the time between something happens and then it get published and then it reviews and then it takes some time, because the system designed this way. So if some people have already data, like us, for example, because we're a large practice, we can have decent data sets and we can prove on our data set that something is working or not, and we can basically improve our workflow and outcomes basically on the fly. And last but not least, it's actually about human beings, about us, because I believe that all this transformation is personal revolution as much as analytical one. I think in medical field we move very slowly because there is a lot of decisions we have to make, and unfortunately, not like in other fields of science, we cannot undo what we did already. So we're moving slowly, but as more and more people, accept and realize the power of ML and data, it's just unavoidable, and we're going to use it a lot in future. But this conception and understanding of the physicians and patients that AI era is here, and we just need to be able to use these tools. So thank you for your attention.
All right. Thanks, Oleksii. We haven't got any questions on Slido, but if there's any questions in the audience, we can take two. Okay.
Great.
Great. Thank you, guys. Thanks. Appreciate it.